Hey guys, I wanted to give you a little help on your homework. This is section 5.3, and we're talking about solving systems of linear equations with a technique called elimination. Okay, so you have a couple different problem sets here. The first set is these 6 problems here, 3 through 8. These are the easiest because they're already set up for elimination. You don't have to do any multiplication. So I'm going to do one of those with you to get you started. The next set here that I'm going to have you do, this next 6, is a little tougher because you have to use some multiplication in order to get things to eliminate. Then you have a couple find the error problems. I always think these are good because they usually pick a common error. So you have 19 at the bottom of the page in the bottom left and then 20 up here, where you're just going to kind of find what went wrong. And the last one is 22, which is a word problem. And we've actually done pretty good at writing equations in standard form, so I'm going to help you set this one up, but I think you'll be pretty good on that one. Okay. What I want you to notice is that most of these equations on this page are set up in standard form, right, with the x and the y on the left and then a number on the right. So elimination is really helpful when you have standard form. Okay, so let me get you started here. Let's start with number 3. That's your first one. We'll kind of help you get going. Alright, so the cool thing about the first 6 problems is they're already set up for elimination. We're going to add the 2 equations together, which basically just means that we're going to combine down the rows, right? The x's are lined up, the y's are lined up, and the numbers are lined up. So x plus negative x is 0. 0x or 0. So we don't write anything here. We actually want those to eliminate. That's great. We got 2y and y, that's 3y. And then we got 13 plus 5, which is 18. Okay, so that's the elimination step. When we have, you know, basically a positive one here and a negative one here, those are gonna cancel out. All right, we need to keep solving for y, so we divide both sides by 3. We get y equals 6. Okay, we're not done yet, but we're halfway there. Remember that a system of linear equations is 2 lines, basically. If we wanted to, we could graph these 2 equations. They would both be lines. They would intersect somewhere, and that's the intersection point that we're looking for. So the solution to a system is an ordered pair, and we don't have an ordered pair yet. So what we need to do is we need to pick one of the 2 equations. Doesn't really matter which one. We need to substitute our y value in, and then we need to solve for x. Okay, so I chose the top one, put in a 6 there for y. So x plus 12 equals 13. Okay, no big deal. We need to get x by itself, so subtract 12 from both sides. And we're going to get x equals 1. Okay, so that's number 1. Or, well, it's number 3. It's the first one you have to do. Okay, and the other, the other 5 that you're going to do are going to be really similar. Notice a y and a negative y, they're going to eliminate right off the bat. A 6y and a negative 6y are going to eliminate. An x and a negative x are going to eliminate. Right? So these are all set up to make that happen right off the bat. You don't have to do any extra steps. Okay? Let's look at the next problem set, starting with 11. Okay, so you're going to do 11 through 16. I'm going to help you get started here on number 11. So the difference between the first problem set and the second problem set is the first one's already ready for you. The second one, you're going to have to do some manipulation. Okay, so what we need is we need something to eliminate here. Okay, we either need the x's or the y's to eliminate. It actually doesn't matter which you do. So a couple options are, if I had something like this, right, those would eliminate. Okay, the other option is if I looked at the y's, I have a 7y on the bottom. If I had a negative 7y on the top, those would eliminate. So one of those 2 things needs to happen. Either multiply the top by negative 2 or multiply the top by negative 7. Let's choose the easier route, which would be to multiply the top by negative 2. So everything on the top gets multiplied by negative 2. That means multiply by negative 2 on the left-hand side of the equation, multiply by negative 2 on the right-hand side of the equation. But don't forget that when you multiply that left-hand side, you're actually going to be distributing, and so really every single term gets multiplied by negative 2, which is going to give us a negative 2x minus 2y equals negative 4. That's just the top equation in a different form. Okay, the bottom equation is still the same. So now it's ready. It's ready to eliminate. Okay, if we combine these two equations, we're going to get another true equation. But now, when we put the x's together, a negative 2x and a positive 2x is going to give us 0. Okay, so they're going to eliminate, which is what we want. Okay, if I combine these two guys, I get a 5y. And then I combine these two guys, and I get a 5. Okay, divide both sides by 5, and so y is equal to 1. Okay, remember, not my final answer, just half of it. Okay, I'm looking for an intersection point of two lines, right? Solution to a system of linear equations is an ordered pair intersection point. So I need to take this number and plug it into one of those two equations. Doesn't matter which one, so I'm going to, again, choose the easy route. Okay, so x plus 1 equals 2. Notice that's the top equation before I multiplied it. X plus y equals 2. Okay, so that's just x plus 1 equals 2. Subtract 1 from both sides, and I get x equals 1. Okay, so x is 1 and y is 1 in this case. And there you go. So you don't have to multiply, you don't have to eliminate the x's, or you can eliminate the y's. It's up to you. I could have just as easily multiplied the top equation by negative 7 and got the y's to eliminate. Okay, so you're going to have to kind of make some choices here. And sometimes it'll be easier or more obvious to eliminate the x's than it is the y's, or vice versa. So if you look at these, for example, okay, I can't multiply this by something and get positive 5. Like, it would have to be a fraction, because 3 doesn't go into 5. In other words, it's really hard for me to get the y's to eliminate in this case. Instead, what I would do is I would multiply by negative 2 so I could get this to be a negative 8x. So in number 12, I would multiply the bottom equation by negative 2. Okay, in 13, it's difficult. You couldn't use a whole number. There's no whole number that you can multiply by 3 to get a negative 11 that will cancel here. So that's kind of a problem. Instead, I would focus on the y's, because it's much easier to multiply the bottom equation by 5. 5 times 4 is 20, and then you'll get your y's to eliminate. So that's what I would do here. All right, so kind of take your pick. In this case, number 14, it doesn't really matter. You could either multiply the bottom equation by 3, which will give you a 9y here to eliminate, or you can multiply the bottom equation by 5, which will give you a negative 10x to eliminate with that guy. So you can make some choices. All right, now what I wanted to do is I wanted to look at 15 with you, because 15 and 16 are a little bit tricky. Okay, so I'm going to kind of walk you through what's going on there. Okay, now here's the thing that's tricky. I can't multiply anything by 2 to get a 3, right, to eliminate here, and I can't get this to be a 5 with multiplication. So it kind of seems like I'm stuck, right? When that happens, when you can't get these to be the same number or these to be the same number with a single multiplication, that means you're going to have to multiply both. Okay, so what I would do is I would think about the lowest common multiple of these two numbers or these two numbers. In other words, what do they both go into? Okay, well, 5 and 4 both go into 20, so I could get both of these to be, 20, like one to be 20 and one to be negative 20. Or I could get these to be like a 6 and a negative 6. Okay, so these both go into 20, that's an option. Or these both go into 6, that's an option. Okay, what I'm going to do is I'm going to change these guys, just because. So both of these numbers are going to change to a 20, but one is going to be a negative. So what would I have to multiply the top by to get this to be 20? Have to be 5, right? So I'm going to multiply everything on the top by 5. So both sides get multiplied by 5. Of course, I'm going to distribute, so each term will then get multiplied by 5. Okay, so that's my new top equation. Now what I want is I want the bottom x to be negative 20. Okay, so what I'm going to do is I'm going to multiply everything on the bottom by negative 4. Okay, so what that's going to give me is the negative 20x that I wanted. Okay, negative 4 times negative 2 is going to be positive 8y, and then negative 4 times negative 11 is going to give me positive 44. Okay, so in this scenario, in number 15 and actually in number 16 as well, you're actually going to have to multiply both equations. You can't just multiply one of them, you have to multiply both of them, which happens sometimes. Okay, so now I'm set up here. So if I combine these two guys, I get 0, which is what I wanted. Here I get negative 7y, and here I'm going to get 84, it looks like. Make sure that that is divisible by negative 7. Okay, so it looks like y is equal to negative 12. All right, now you're going to have to plug that back in to find your other value. So I'm going to take this guy, I'm going to plug it into probably one of the original equations. We actually have 4 equations now, and it doesn't really matter which of the 4 we use. They're all going to give you the same answer. I could use this one, this one, this one, or this one. Like I said, it doesn't matter. Let's use the bottom original. So 5x minus 2y equals negative 11. That was the original down there. So let's substitute. So 5x minus 2y, but y is negative 12, equals negative 11. Okay, remember, always substitute into parentheses so that we can see that this is actually a multiplication here. Okay, and we'll subtract 24 from both sides. So 5x equals negative 35, and x equals negative 7 if you divide both sides by 5. Okay, so there you go. We got our solution there. Sorry if you're hearing that buzzing. My computer is, I think it's getting hot, and the fan just kicked on. Okay, so that's how you're going to do those. Now 16, same kind of idea, right? Like, let's take a look. You're going to have to multiply both of these equations to get this to work. Okay, so figure out what number do these both go into? What do 3 and 2 both go into? Right? They both go into 6. And so you could get a 6 and a negative 6. Or you could do, these both go into 55, so you could get like a 55 and a negative 55 here. Up to you. That's how you're going to do it. Okay, then you have the 2 error analysis questions, right? So this one, number 19, kind of figure out what went wrong here. That one's actually pretty easy to spot the error. Okay, and you got number 20, so figure out what's happening when they multiply everything in the bottom equation by negative 4. See if you can figure out what's going on there. And again, that should be pretty easy to spot. Okay, the last one is 22. Now, you actually probably could set this up on your own because we've practiced writing equations in standard form before. But, sometimes you'll see a word problem on your homework and you'll freak out and not even try it. Okay, but let's see if we can do it together. All right, so a music website charges X dollars for individual songs and Y dollars for entire albums. Person A pays $25.92, to download 6 individual songs and 2 albums. If I were to stop right there, you could probably write an equation for that guy. Okay? I don't know how much the songs cost. I don't know how much the albums cost. I do know my total cost, and I know how many of each I've bought. Okay, so here's the deal. This is kind of how you're going to set this guy up. Okay, so person A, We got person B. For person A, they have 6 songs, but